Hello and welcome to Chemistry with Mr. Olson. Today we are going to solve some basic stoichiometry problems using our basic stoichiometry worksheet. And remember, lists of ions are available on our pink reference sheet. Okay, we're going to do some problems such as grams to moles to grams. And here is our roadmap, which shows us how we can go from grams of X to moles of X using the molar mass of X. We can go from moles of X to moles of Y, from one substance to another using the Molar Ratio from the balanced chemical equation. And we can convert from moles of Y to grams of Y using the molar mass of Y. So we're going to do a couple of examples. First, question 2. In our worksheet, sodium reacts with chlorine gas to produce sodium chloride. Write a balanced equation. Sodium reacts with chlorine gas, that's a diatomic Brinkelhoff element, to form sodium chloride. Sodium chloride, useful always to remember, translate out the ions, and then you can figure out the balanced formula. That is going to be NaCl. Once we have the formulas correct, then we take out our pencil and we adjust the coefficients. We're going to need 2 chlorines on each side and 2 sodiums on each side, and now we have the balanced chemical equation. All right, our question is how many grams of chlorine gas are needed if 4.0 moles of sodium react? So our given is 4.0 moles of sodium. That's our moles of X. And we're asked how many grams of chlorine. How many grams of chlorine gas are needed? So we're going to need 2 conversion factors. And we are going to go from moles of X to moles of Y, and then from moles of Y to grams of Y. And that will look like this part of our whole stoichiometry roadmap. So let's write the given, 4.0 moles of sodium. And then our first conversion factor is a molar ratio. We get out of moles of sodium into moles of Cl2. That's our moles of X to moles of Y. Moles ratio. For the coefficients, we look in the balanced chemical equation. It's 2 moles of sodium. 2 moles of sodium react with 1 mole of chlorine. So there's our ratio, a 1 to 2 ratio. And that gives us the moles of chlorine. But we still want to, the question asks for grams of chlorine. So we have one more conversion factor. Out of moles of Cl2 into grams of Cl2. How many grams per mole, in other words, how many grams per 1 mole of Cl2? And that is the molar mass of Cl2, and I have written that out right here. 2 chlorines from our periodic table, that's 71.0 grams per mole. So that's 71.0 grams per 1 mole. All right, now my favorite part, moles of Na cancels moles of Na, moles of Cl2 cancels moles of Cl2, and we multiply out the answer. And let's check sig figs first. On my calculator, that comes to 142, but we only have 2 sig figs, so we'll round that to 2 sig figs. 140. 140, what are our units? Grams of Cl2. And that is our answer. We can check that on the back, and we see indeed the answer to 2B is 140. Don't forget the units, grams of Cl2. Okay. So, next question is question 3, A, B, and C. Lead 2 nitrate and sodium iodide react to form aqueous sodium nitrate and solid lead 2 iodide. Which product is the precipitate? Well, the solid that's formed out of the aqueous solutions is the precipitate, so that would be the lead 2 iodide would be the precipitate. Lead 2 iodide is the precipitate. Nice to make the answer stand alone rather than just float out in space. Okay, write the balanced equation. Okay, for that we need to decode what are the formulas of these. And lead Roman numeral 2 is Pb plus 2. Nitrate, we can look that up. It's NO3 with a -1 charge. Sodium as an ion is Na plus 1. And iodide is I minus 1. We know that because of where they are in the periodic table. Plus 1. And iodide minus 1, a halogen. Okay, so let's translate this equation. Lead 2 nitrate, we need 2 nitrates. So that would be PbNO3 2 plus, leave space for a coefficient, sodium iodide. Well, that's concise. NaI. React to form aqueous sodium nitrate. So sodium nitrate, that's NaNO3, leaving space for coefficient, plus, what is our other? It's the lead 2 iodide. So lead plus 2 iodine minus 1, that'll be PbI2, balancing the charges. Now that we have the formulas of the substances right, balancing the charges within these ionic compounds, now we can take out our pencil and we can balance the equation. And it looks like, let's see, 2 nitrates on the left, so we need 2 nitrates on the right. We have 2 sodiums. We'll need 2 NaI. And let's see, the iodines work out. So that's our balanced equation. Now we can do the calculation. How many moles of sodium iodide react with 257 grams of lead 2 nitrate? So we have 257 grams of this substance here, and that is our given. We are going to go from grams of lead 2 nitrate to moles of lead 2 nitrate using the molar mass, and then from moles of lead 2 nitrate to moles of what it asks about, sodium iodide. So this is a grams to moles conversion. All right, let's write down our given. We are given this quantity, 257 grams of lead 2 nitrate. I could write out the formula. That would be beautiful and elegant, but I'm going to abbreviate it. I'm just going to say capital L, capital N, just for convenience. LN, that's my abbreviation. 257 grams of lead nitrate, and now we need the first conversion factor. We're going from grams of X to moles of X. Grams of Ln out of grams of Ln to moles of Ln. And we need to know how many grams per mole of Ln. Well, let's see if I can put on the screen. There's my molar mass calculation for lead 2 nitrate. 1 lead, 2 nitrogens, 6 oxygens. Of course, these masses are all grams per mole from the periodic table. There's lead, 207.2. And I added up, I get a molar mass of 331.2 grams per mole. All right, so that's why I put here 331.2 grams of lead nitrate per mole. All right, that's my first conversion factor. But I need another one because the question asked not for moles of lead nitrate, but for moles of sodium iodide. So I'm going to get out of moles of lead 2 nitrate into moles of sodium iodide, NaI. There we go. Now the mole ratio. For that, I look to my balanced chemical equation. 1 mole of lead 2 nitrate reacts with 2 moles of sodium iodide. So I put a 1 there and a 2 there. And now my favorite part, the units cancel. Grams of Ln cancels grams of Ln. And moles of Ln cancels moles of Ln. And we get out our calculator. 257 times 2 divided by 331.2. And that comes out to a long number, 3 sig figs, long. It's 1.55 moles of NaI. And that's my answer. And on the back, 3C. 1.55 is the correct answer. So there we go. That's how we do it. That was an example of grams to moles to moles. I hope this has been helpful. I hope you have a wonderful rest of your day. That's been chemistry. Where is my menu? Ta-ta.